video in which I'm going over 5 basic Pytorch operations. Now these operations are quite basic. You probably know some of them already or all of them, but I do encounter here and there people who have not practiced them much or are not really familiar with them inside out. And this is something that can actually slow you down when you want to do model training, you want to do certain arrangements of your tensors, and you want to know how to reshape dimensions or add a dimension and so on and so forth. And if you are not really practicing this, then a lot of your brain power goes into finding out how to do these operations. So it's always good to know what is possible, what are the basic operations in Pytorch. And for this purpose, I'm going over them and practice them here. So what I'll do first is just gonna install my Torch library, import that, and then I'm going over the first method here, which is arrange. And arrange is just like the Python range that you start with a declaration of what is your starting value, and then your non-inclusive stopping value, and then your step size. And what that means is you start at 0, go by steps of 10 in this example, you go all the way to 100, but you don't include in 100. So this then also goes all the way to 90. Now you can change your step size to 5, and that means then exactly that. You step in numbers of 5. And if you don't include a step size at all, by default, the step size is 1, as you can see here. Also, what you can do is you can do a range from higher number to lower number in a negative step size. And then that does exactly what you would expect. It counts down in steps of 2 all the way to 2, and the 0 is not included. The next method I want to go over is reshape. And reshape is quite useful or quite necessary in a lot of examples that we can go over. So here, for example, we have this tensor of 16 values that I just created with arrange. And now I want to reshape the dimensions. And what I have now is the same values, but in different dimensions. 4 rows, 4 columns. I can do the very same thing. Also 2 by 8, whatever multiplies to 16 in this example. I can also just make it one singleton dimension here, and then I have this tensor here. Note the difference is here, there's one more bracket around it now. Now also one way to achieve adding a new singleton dimension is to do this reshape -1, 1. And what that will do is you still have that tensor here with the 16 numbers, but the dimension you actually added is the 0th dimension here. So now you have 16 rows of numbers and 1 column of such. The next method I want to show is view. And view is very similar to reshape, but it does one thing different. View does not return a new tensor. View returns a new view on the data. And that has some implications. For example, whatever you change on that new object will also be changed in the original tensor object. So to illustrate that, we're going to again create our tensor x here with the 16 entries. And now I'm going to run view on it. And as we've seen in the previous example, this adds me this column dimension here in the 16 rows. And now if I want to manipulate this object here, this view of the same tensor, and let's just add a very noticeable number to this, 555. Then of course, this will be reflected in this new object that I see here. Yeah, the first entry is 555. But what about that original x, the one that we called the view on? This is where we called the view on. Did that change as well? And the answer is yes, it did, right? On this very first position here. So that is a difference between reshape and view. View just gives you a new view on the data. It actually does not create a new tensor object. The next two methods that are always very useful are squeeze and unsqueeze, and they deal exactly with these singleton dimensions, these dimensions of value 1. And to illustrate that, let's again create our 16 entry tensor here. Now I'll do the first unsqueeze on that. In unsqueeze, I also add a dimension. So I'm going to add dimension 0 here. And what that does is it adds that singleton dimension in the zeros index here. So this gives me 1 row, 16 columns out of this original tensor. If I choose the dimension to be 1, then it does exactly the opposite, and that's again like an X reshape, for example. Reshape -1, 1 would give me the same kind of tensor in this case. And if I want to remove these singleton dimensions from any tensor, what I can do is I'll take this tensor y that came out of here and squeeze it and see what happened. Now it's removed down to its just in one-dimensional format here, and the singleton dimension is squeezed out. Same would be with the tensor z that I have here. If I squeeze z, what we'll see here, the dimension is 16. Again, same tensor comes out. Now, that might be interesting to see actually how often would I have to call squeeze if I have multiple singleton dimensions. So here I'm going to call unsqueeze and unsqueeze again on that original tensor. And as you would expect, you have added 2 of these singleton dimensions. It looks like this, 3 brackets. And if I call now squeeze 1 time on that, it will squeeze away all of these singleton dimensions. So I only have to call it once if I want to squeeze them away. And here is the original tensor again. The final method that I want to look at is repeat. Repeat is also quite basic, but always quite useful. So if we start with a tensor of these 3 entries here, 4, 5, 6, and let's say I call repeat with the number 3 on it, what happens is exactly what you might expect. Our size increases 3-fold, and we have exactly this original sequence repeated 3 times. Now we can also add multiple numbers here, and that will repeat it in the respective dimensions. So the 4, 5, 6 now gets repeated in this direction and also in the row direction. The tensor that you put in doesn't have to be one-dimensional. You can put, for example, any dimensional tensor in there. Here's a 2 by 2. And if I do a repeat 2 and 4, then what I expect to happen is that I repeat this tensor twice in this direction, in the row direction, and 4 times into the column direction. So let's look. And that exactly is what happens, right? So here we have the original tensor 5, 6, 7, 8, and it repeats itself in both directions. And so the outgoing dimension is the original dimension multiplied with these numbers that I fed in here. So that makes 4 and 8. I hope you find this useful. I hope you enjoyed it, and I look forward to seeing you in one of my next videos. We're going to go into deeper things, deeper modeling and training, and that's where we're going to be using these types of operations quite regularly. So thanks again for watching, and see you soon.